keep going. For task 4, we're going to be using a website to actually look at the sequence of the TAS2R38 gene. All right. So we're going to click on this. I'm going to make sure I'm sharing my screen for this website. I can't share two like documents at once. So without having to do a split screen. So what I'm going to do is use the website and read along what I'm doing on the task sheet. All right. So I have my task sheet open on another page and I'm just following along what it says. All right. So what it's telling me to do is click here and actually type in the name of the gene. So the gene that we're searching up again is still the one correlated with the ability to taste PTC. So TAS2R38. I'm gonna make sure I'm searching this in Homo sapiens because this is a gene that we have. And then I'm just hitting search. Depending on your computer, this might take a little bit to load. Think about it, you're loading in thousands of nucleotides and the entire gene, essentially, so you can actually look at it and look at all of the SNPs. Okay. So I'm going to wait for this to load. And then this is what's going to show up. Okay. So it is a lot. And I'm going to try to walk through this step by step and basically as simply as I can. All right. So the first question the task sheet is asking me is to look at where TAS2R38 is located. All right. On what chromosome. So on the left here, the actual program highlights where on the genome it's located. So in this case, my TAS2R38 gene is located on chromosome number 7. That's where the gene is, and that's where it's coded for. Okay, so for that answer, TAS2R38 is located on chromosome number 7. Number 13 on the task sheet is asking us to identify the length of the gene, the length of mRNA, the length of protein, and then whether or not this gene has introns. So before I even get into actually analyzing my gene, I have to switch the DNA tracks. So I don't know if you guys can see, the DNA is currently pointing to the left. I need it to be pointing to the right in order to fully analyze it correctly. So to do that, I'm right-clicking on the green strand, and I'm clicking flip the sequence strands. So once again, I just right-clicked it and put flip sequence strand, and then now my arrows are pointing to the right. Okay, so to get all the information that the task sheet is asking for, I'm just hovering over my strand, and it's telling me that my TAS2R38 gene is 1,143 nucleotides long. Okay. Now, in order to get my mRNA length, this top green is my actual DNA. This bottom one is my mRNA. Okay. So the length of my mRNA, which is this bottom strand, is also 1,143 nucleotides. Okay. When we say, I'm going to skip to question D really quickly. When we're trying to figure out if a gene has introns, we look at the length of the DNA versus the mRNA. So in this case, since my DNA and my mRNA are the same length, that means that nothing was cut out during transcription. So if nothing is cut out during transcription, that means there were no introns for my gene. If there were to be introns for this gene, you would see that the mRNA would be a lot shorter, or not always a lot, it could just be a little bit shorter, because introns are sections of DNA that aren't expressed, so they're cut out. So that would mean that my original DNA would be longer than my mRNA. In this case, nothing was cut out, so they're both equal lengths in nucleotides. Okay, so far my answer to A is 1,143. My answer to B is 1,143 nucleotides. My answer to D is no. The answer to C is right here. The protein length is 333 amino acids long. Cool? I'm moving forward. All right, so now we're looking at our actual variations. So like I said, there's going to be 3 single nucleotide variations at the respective locations we talked about. So 49, 262, and 296. All right, So they're actually in order on the program. This is my one located. Okay, I'm starting again for the third time. So I have my DNA strand up here, and it actually highlights the SMPs for you, the variations on this website. So on my actual task sheet, it says that the first variation ID I'm looking for is RS713598, and that one is located right here. I see it here. All right. So to find the nucleotide position and all of that, the easiest way to do this is to actually pop up my zoom to sequence. Okay. So as you can see, this kind of scooted over here. So I'm just going to scooch over using this. It's highlighting it. I'm going to pop this open. And then once I click on my green DNA strand, it'll pop up the mRNA and then the actual codons that go with it. All right. So if I look at my first variation, I hover over the amino acid sequence that goes with it, it'll tell me everything. Okay. So the position for this variation for the nucleotides is 141,973,544. Okay. The codon that goes with it is GCA. The amino acid is A, and I'm looking at that information right here. And then the table also asks me for the protein position. That information is right here. So that's my first variation. The person with this specific gene that's in the library has the amino acid A. Okay. So now I'm going to scroll down the line to look for my second variation ID, which should end in 866. It's right here. All right. So for this one, my nucleotide position, I'll show you guys right now, is 141,972,905. And this is the protein position 262. And if I scroll back out, my amino acid is GCT. My codon is GCT, and then my amino acid is A. Okay. So for this one, the library has it as the amino acid being A. This is supposed to be a V. All right. If you actually look at the protein, the amino acid chart, it codes for V as well. So I'm not sure why it says A here, but V is the correct answer. All right. Especially for a task sheet. Okay. And then for the last variation ID that we're looking for, it should end in 939. So I'm going to scoot over until I see it. Let me go a little bit more. 939, it's this one. So the one that shows up here, my codon is ACT or ATC. And then my amino acid is I. Okay. For my nucleotide position, it shows right here. 141,972,803. And then my protein position is 296, which is again the last position of those SNPs that we look for. So in this case, the person on the NIH website, there are 3 amino acids at the SNP locations for the TAS-R38 gene are AVI. So this person whose genome we just looked at is not a taster. Okay. For the last task on your task sheet, let me share it again. We're going to cut this out. All right. So for task 5, ignore it. Don't fill it out. Cut it out of your task sheet. You can delete it. We're not going to do it. It's honestly a lot. So just go up to task 4. I'm going to show the answer key really quickly, just so you guys can look at it, and I'll go over it one more time. This is the chart that I was filling out as I was looking at those variations on the NIHI website. So for the first variation ID, again, the amino acid was A, codon was GCA. For the second variation, it showed an A, it's supposed to be a V. And for the last variation, it was an I. So at these 3 protein positions, this person showed AVI amino acids, which means this person that we looked at is a non-taster.